Welcome to the deep dive. So today we're diving into an idea that, well, it might just flip your understanding of intelligence right on its head. We're talking about tool use. For the longest time, we kind of thought this was our thing, right? Purely human, a sign of our, superior intellect.
A defining characteristic.
Exactly. But what if I told you it's really not unique to us at all? You might be surprised.
That's right. And it's not just about animals, interestingly. This whole idea connects back to us, to human evolution. Our growing reliance on making tools, it fundamentally shaped our intelligence. It let us compete differently, rely less on just brute strength.
Right.
And now we're kind of at the next frontier. Our most advanced creations, AI agents, they're becoming tool users. Not just tools we use, but systems that use tools themselves autonomously.
Right. So that's our mission for this deep dive then, to explore this agentic web. It sounds like a really pivotal shift in how we deal with information, with services online, and, crucially, what it means for you.
Okay, let's unpack that idea first, tool use beyond humans.
Yeah.
Because like I said, for centuries, the belief was pretty firm. Only Homo sapiens did this. It was the marker of being smart.
Yeah, that was the standard thinking, but the research now shows, well, it's just not true. The animal kingdom is full of surprises here.
Like what?
Okay, well, take humpback whales. They create these things called bubble nets.
Bubble nets.
Yeah, they blow these incredibly precise patterns of bubbles. They control the size, the depth, the spacing, all to trap krill. Researchers actually call it wholly unique to them. It's quite complex behavior.
Wow. Oh, that's more than just instinct.
Definitely. Or think about New Caledonian crows. People call them crafty crows.
Crafty crows. I like
They
that.
don't just find objects to use as tools, they actively make them.
They make them, yeah. They'll trim twigs, bend leaves, even wire, using their beaks to make hooked tools.
Hooks for what?
Perfect for pulling larvae out of tree bark. And this ability, making a tool for a specific job, it's rare. It shows advanced motor skills, sure, but also cognitive stuff, like planning ahead, having insight.
Actually crafting tools. Yeah.
It really does shift the perspective on animal cognition, doesn't it? It suggests some kind of abstract thought.
It absolutely points that way. And there are more examples. Sea otters, they use specific rocks, stationary ones, as anvils.
Anvils.
To crack open muscles. And they do it so consistently that it leaves, archaeological traces, where patterns on the rocks, piles of shells building up over years, even decades.
That's amazing. So it's a learned, persistent behavior.
Exactly. Even burrowing owls. They do something quite clever. They put mammal dung around their burrows.
Gun. Why?
Not for decoration. It lures dung beetles, which the owls then eat. It's basically baiting. Okay, that's strategic. From whales to crows to owls. It really forces you to rethink that human-centric view of intelligence. But the real sort of aha moment for us today, for this deep dive, is how this reevaluation of tool use connects directly to AI, right?
Precisely. Because if you look at human evolution, our intelligence was massively shaped by needing to make and use tools that helped us compete, reduce the need for just physical power. There's this cultural intelligence hypothesis. It suggests our big brains, our smarts, grew over generations because we could pass on knowledge culturally through social learning faster than genes could change.
As opposed to the social brain hypothesis.
Right, which links brain size more to handling complex social groups. But the tool use aspect is key for this discussion.
So, okay, what happens now? When our most advanced creations, AI, start becoming these sophisticated tool users themselves. It feels like history repeating, but, with silicon.
Yeah.
Yeah, exactly. And it's not just the concept of intelligence changing. The internet itself, the infrastructure, it's transforming to support these new agents. Let's maybe trace that evolution. Where did the web start?
Okay, yeah, we can think of it in roughly 3 stages. First up was the PC web era.
Right. Dial-up sounds?
Maybe. But functionally, it was about information directories, the search paradigm. Content was on static web pages. You manually browsed or searched. Then search engines got smarter. PageRank from Google was huge, that idea of link-based voting for relevance.
Yeah.
And that's also when the commercial web really kicked off. Keyword ads, auction systems like AdWords. Things got sophisticated quickly. But fundamentally, it was about connection, finding information.
It's like a big digital library or Yellow Pages.
Pretty much. Then came the mobile web era. This was a big shift. Suddenly, it was all about recommendation.
Because there was just too much stuff.
Yeah, exactly. An explosion of user-generated content, plus the smaller screens on phones. Curation became essential. So deep learning methods took over. Things like neural collaborative filtering, transformers. They enabled real-time personalization. Your feed started learning what you liked.
Right, every click, every pause.
Became a data point. Yeah. This fueled the attention economy.
Yeah.
Showing you relevant stuff, showing you relevant ads. It was all about keeping you engaged.
That's the web most of us know now, I guess. Personalized feeds, targeted ads.
Yes.
Yeah.
And now we're entering, or maybe we're already in, the Agentic Web era. This is driven by the big breakthroughs in large language models, LLMs. The web is shifting towards intelligent agents coordinating complex tasks for you.
Okay, define agent here.
Think of an AI agent as a piece of software that can perceive its environment, it can reason, and critically, it can take autonomous actions to achieve goals that you set for it.
So it does things.
Yes. It can plan, it remembers past interactions, it can use tools like APIs to interact across different digital systems,
Right.
It can handle complex, long-horizon tasks, and you can even have multiple agents working together, orchestrating tasks. It's moving from us clicking buttons to, well, machine-to-machine interaction, delegating your intent.
Letting the agent handle the routine digital stuff.
Exactly. Relieving you of that burden.
And you mentioned these agents are getting better quickly.
Oh yeah, the growth is, well, it seems exponential. There's data suggesting that the length of tasks agents can manage with, say, an 80% success rate. That capability is doubling roughly every 213 days.
Doubling every 7 months or so. That's incredibly fast.
It really is. It signals a rapid acceleration in capability. So to really get a handle on this shift, maybe we should look under the hood a bit. What makes an AI agent work?
Yeah. What are the components?
Okay, think of it like this. At the core, there's usually a foundation model, typically a large language model. That's the brain, providing the reasoning and understanding. Then you need memory, both short-term to keep track of the current conversation or task.
Like working memory?
Right. And long-term memory to store and recall vast amounts of information over time. This often uses things like external vector stores, specialized databases.
So it learns and remembers across interactions.
Crucially, yes. Then there's a planning component. This breaks down a big complex goal into smaller manageable steps.
Like a to-do list.
Sort of, yeah. And then tool using capabilities. This is vital. LLMs aren't perfect at everything, right? They might struggle with complex math or need real-time external info. So the agent needs to be able to call on external tools, APIs, databases, other services to overcome these limits. Think of the tool former concept.
Okay, so it can use a calculator API or a weather API or book a flight.
Exactly. And finally, action execution, the ability to actually do those things. Make the API call, interact with the system.
Let's take that Beijing trip example. If I ask, plan a 3-day trip to Beijing.
Right. An agent system might work like this. Maybe a request parser agent figures out the key details, location, duration. Then a tool orchestrator agent breaks it down. Check weather, find attractions, check hotels, map routes. And it calls the specific services or APIs for each of those subtasks using some kind of protocol.
Okay, that makes sense.
But this leads us to a really important point. The biggest hurdle right now for these agents, it's not really the complex reasoning anymore. They're getting quite good at that.
Oh, what is it then?
It's the lack of standardized communication protocols.
How they talk to each other, to other systems.
Exactly. It's like, imagine trying to build a global economy if everyone spoke a completely different language with no translators. Right now, it's fragmented, lots of proprietary standards, different ways of prompting or calling tools. This really hinders interoperability, makes things more complex and costly. It's the main bottleneck.
So what are they speaking now? Or what are the attempts at creating this common language?
Well, it's an evolving space. There were early attempts back in the 90s, actually. Things like KQML, the knowledge query and manipulation language, and then FIPA ACL, the FIPA agent communication language from 96. FIPA ACL was quite advanced for its time.
How so?
It treated communication as speech acts. Like messages weren't just data, they were actions, informing, requesting, promising. It even tried to model the agent's mental state, its beliefs or intentions behind the message. And it defined interaction protocols, rules for message sequences.
Wow, so trying to mimic the nuances of human conversation in a way.
In a structured way, yes. Now, fast forward to today, we're seeing modern protocols emerge. There's the Model Context Protocol, or MCP. Think of this as model-centric. It uses a client-server setup, often uses standards like OAuth for authentication. It's key for letting agents connect to existing web resources, existing tools.
Like plugging into the current internet.
Pretty much. You see it in banking, for example. MCP-like protocols are enabling automation of routine queries, cutting operational costs significantly.
But you mentioned risks.
Yeah, a big security challenge with MCP is making sure you decouple the tool calls from the LLM's response generation. Otherwise, you risk private user info accidentally getting sent out when an external tool is called.
Okay, that's a serious privacy concern.
Definitely needs careful implementation. Then there's the agent-to-agent protocol, A2A. This is more enterprise-focused. It uses something called agent cards, basically little profiles in JSON format to advertise what an agent can do. This helps specialized agents within a company find each other and collaborate.
So more for internal corporate use.
Often, yeah. But then you have something like the Agent Network Protocol, ANP. This is maybe the most ambitious. It's agent-centric, envisioning a peer-to-peer network.
Peer-to-peer, like BitTorrent.
Architecturally, sort of. It uses W3C decentralized identifiers, DIDs, for cross-platform authentication, which is simpler. But the really crucial part, ANP uses semantic web link data.
Link data.
Yeah. The idea is to build a new data network that's structured specifically to be easily accessible and understandable by AI. It's like building an AI access web that sits alongside the human web.
Whoa, so a web built for AI, not just used by AI, that's a paradigm shift.
It really is. And there are others too. The Coral Protocol aims for an open, decentralized framework covering communication, coordination, trust, even payments between agents from different organizations. And for negotiation, there's the ContractNet protocol. Simple idea.
All right.
A manager agent broadcasts a task, contractor agents bid for it.
Okay, so lots of different approaches trying to solve this communication problem.
Right. And the goals for all of them are similar. High efficiency, low latency, low resource use. Scalability handling potentially millions of agents. And extensibility being flexible enough to adapt as things evolve.
Now, you mentioned payments in there. If agents are doing tasks, calling services, they'll need to pay each other, right? Which brings us to this whole idea of machine-to-machine payments, M2M.
Exactly. And this bumps up against a historical problem. Micropayments.
Tiny payments.
Yeah, very small sums. Traditionally, these were just economically unviable. Why? Because standard payment systems, like credit cards, have transaction costs that are just too high for, say, a fraction of a cent. They're built for human scale transactions.
Right, the fee would be more than the payment itself.
Precisely.
Yeah.
But gaming kind of paved the way here.
Ah, yes. Buying extra lives, virtual items.
Exactly. The gaming industry totally normalized micropayments through in-app purchases. Think about mobile gaming. It's huge, projected over $250 billion globally soon. It shows people, especially younger users, maybe without credit cards, are perfectly comfortable making frequent, small digital payments.
Okay, so we're culturally primed for micropayments now. What does that mean for the agentic web?
It means the timing is right. As more services get digitized, especially with the Internet of Things, IoT, payments are naturally getting smaller and more frequent. IoT could be the biggest driver for micropayment in M2M.
Can you give some examples?
Sure. Imagine industrial machines automatically ordering and paying for their own replacement parts when sensors detect wear. Or a smart supply chain where robots manage and pay for logistics steps. We're already seeing early versions. Cars that can autonomously pay for fuel or parking.
Yeah, I've heard of that. It's already happening.
It is, in pockets. But a major hurdle is the sheer complexity of billing and accounting. If you have potentially millions of agents spontaneously collaborating, consuming tiny bits of service from each other, how do you track all that? You need a really robust, auditable system.
So what are the potential solutions for handling these M2M micropayments?
Well, one area getting a lot of attention is blockchain and distributed ledger technology, DLT.
Crypto.
Not necessarily cryptocurrency, but the underlying ledger tech. It offers potential for secure, transparent, resilient transactions. Could enable models like device as a service. You lease a device, and it pays automatically via smart contracts using tokens.
Okay, but what are the downsides?
Well, with public DLTs, there are questions around governance, who's in charge, and the lack of a central authority to step in if things go wrong. Risk mitigation can be tricky.
Right. What else?
Another possibility is central bank digital currencies, CBDCs.
Government-backed digital money.
Exactly. Because it's legal tender, it could offer super low-cost, instant global payments. Ideal for micropayments.
But the risk's there.
If you lose your private key, your money could be gone. Plus, integrating CBDCs into existing frameworks for preventing money laundering and terrorism financing, AML-CFT, presents new challenges.
Okay. And technology like 5G plays a role.
Absolutely. 5G speed and security are big enablers. Faster data transmission allows for more complex AI and chatbot services, even in small payment terminals. And it helps connect mobile devices to in-store IoT for better personalization, which can tie into payment systems.
This isn't just a technical footnote then, it's a huge economic shift. You mentioned the market size projections.
Yeah, the M2M services market.
Yeah.
Projected to grow from around $47 billion in 2023 to over $424 billion by 2034. That's nearly tenfold growth.
Yeah.
It's a massive transformation underway. But as these agents become more autonomous, more capable of acting in the real world, or at least having real-world consequences, the risks go way up.
Right.
Building trust becomes absolutely paramount. And it's shaky right now. There was a recent survey showing only about 27% of organizations trust fully autonomous AI agents.
Only 27%. Wow.
Yeah, and that's down from 43% the year before. Suggests maybe the initial hype is wearing off and a dose of reality is setting in about the challenges.
Okay, so what are those big challenges? What makes it hard to trust these agents?
One major one is over-autonomy and goal drift. The agent starts with one goal, but over time its actions might diverge. Subtly or not so subtle.
How do you prevent that?
It's about designing for controlled autonomy, building in human-in-the-loop or HITL checks, especially for critical decisions, having rules-based checkpoints, and crucially, having override and rollback mechanisms. HITL fosters collaboration, not just delegation.
So keeping humans involved at key points.
Especially for high-stakes actions, yes. Another challenge is memory bottlenecks. We talked about memory, but managing potentially gigabytes of data from ongoing interactions, turning it into useful embeddings for long-term recall. That's a significant infrastructure problem. It's not just plugging in a database.
Right, the scale is different.
Definitely. And then there's data quality and cost. Good data is the fuel for these agents, but it's often expensive, messy, stuck in silos. Organizations really need to focus on data readiness, building clean, compliant data lakes, using privacy-preserving methods.
Garbage in, garbage out still applies.
More than ever. And finally, just continuous maintenance. Agents aren't set it and forget it. Prompts need tuning. APIs they rely on can change or break. User behavior evolves. They need constant upkeep to handle new edge cases.
Okay, those are reliability challenges. What about actual security threats, if they're acting, not just responding?
Exactly. The attack surface is much larger, and the potential damage is higher because they often have access to sensitive systems or data.
So what kind of attacks are we seeing?
There are new vectors. One is perception and interface hijacking. An attacker manipulates what the agent sees, maybe hidden data on a web page, or interferes with how it interacts with web elements, tricking it into doing something unauthorized.
Tricking the AI's senses.
Essentially, yes. It could be hidden markdown comments in a forum post, for example, that the agent processes but a human wouldn't see. Then there's prompt-based hijacking. This is really insidious. It targets the agent's internal reasoning loop. Attackers craft specific language, hide it within web content the agent consumes, and exploit the LLM's flexibility to subtly bend the agent's reasoning towards a malicious goal without ever touching the agent's code.
Wow, that sounds incredibly hard to defend against.
It's a major challenge. And it gets worse with context leakage. Agents handle sensitive data all the time. It can inadvertently leak out, especially if you have multiple agents working together. If one agent in a chain is compromised, it could expose data from the entire task sequence.
A domino effect.
Potentially, yes. And don't forget IoT devices. They're often the weak link. Poor security, default passwords, open remote access. They can be targeted for surveillance, tracking, or co-opted into botnets for launching massive DDoS attacks.
Okay, so the risks are significant. What's being done to build that trust, to make this safer?
A huge part of it has to be human-centered UX design. We need to design these autonomous systems so they genuinely align with human needs and values.
What does that look like in practice?
It means agents should provide real value, not just novelty. They should offer hyper-personalization, truly treating you as an individual, adapting in real time. They should be proactive, hinting, reminding, alerting when appropriate, and maybe even show some emotional intelligence, detecting frustration or excitement and responding accordingly.
Making them feel more like partners.
Exactly. And authenticity helps. An AI that says, I don't know that yet, but I can try to find out, feels more trustworthy than one that just makes something up or deflects.
That makes sense. What else?
Developing and embedding ethical AI guidelines is critical. This isn't just a policy document, it needs to be built in.
How?
By embedding ethical reasoning into the agent's design so it can identify potential ethical dilemmas and flag them for human review. By ensuring decision-making is traceable and auditable detailed logs, clear reasoning chains, and by creating layered governance.
Layered governance.
Yeah, having multiple agents where some can critique, supervise, or even override others. like having a dedicated guardian agent oversee high-stakes decisions made by another agent.
Checks and balances for AI.
Kind of, yes. And having dedicated AI ethicists within organizations is becoming vital. They help define the ethics code, ensure the right questions are being asked during development, and set up compliance and escalation processes.
This whole discussion about managing agents, data, efficiency, it reminds me of something called Jevons paradox. How does that fit in?
Yeah, that's a really interesting connection. So Jevons paradox, traditionally in economics, observed that as technological improvements made using a resource like coal more efficient, the demand for that resource actually increased rather than decreased.
More efficiency led to more use.
Exactly. And we see a similar thing with AI and data. As the tools and techniques for ingesting, storing, and analyzing data become cheaper and more efficient, the demand for data and its perceived value just keeps growing.
So better data tools make us want even more data.
Precisely. Which means that cost-effective, long-term data retention becomes strategically important. You need large, high-quality data sets to train better AI agents and gain deeper insights. Think about CDN logs, content delivery network logs. They used to be seen as sort of throwaway operational data.
Right, just server access records.
But now, they're incredibly valuable for training AI models to understand user behavior patterns, personalize ads more effectively, even detect subtle security threats like low and slow attacks that might otherwise be missed. The efficiency gains in storing and processing that data made it valuable. So pulling all this together, what we've really explored today is that this agentic web isn't just, another tech upgrade. It's a fundamental strategic shift in how value gets created, captured, and exchanged in the digital world.
Yeah, it sounds like it forces a rethinking of roles, workflows, even the basic relationship between people and software. It's about forging a new kind of maybe human AI chemistry.
That's a good way to put it, where humans and agents work together effectively, each playing to their strengths, with clear roles, intuitive interactions, and hopefully mutual reliability.
So for businesses, for individuals listening, what are the key takeaways? What should they be thinking about?
Well, for businesses, making your content, your services agent accessible through standardized APIs becomes critical. If agents can't easily interact with you, you risk becoming invisible on this new web. Also, developing new skills internally around agent experience design, agent governance, ethical oversight. That's crucial. And be prepared for middleman elimination. Agents might start mediating interactions directly, bypassing traditional intermediaries.
Right. So we started by looking at how animals surprised us with their tool use. And now we're seeing AI agents emerge as these incredibly sophisticated tool users in their own right. They're negotiating, learning, acting autonomously in our digital world. It really makes you wonder, what new kinds of intelligence, what new forms of collaboration might emerge from this? When our digital tools aren't just extensions of us, but become tool users alongside us, navigating this increasingly agent-mediated landscape. And perhaps the most important question for you, the listener, what does all this mean for your own agency, your own autonomy in this evolving digital future?